Calculating three-phase transformer values can be overwhelming due to the many formulas involved. Thankfully, there's a shortcut that lets you skip most of the complexity. Below is a quick reference for each major winding configuration, making it easy to find secondary voltages or currents without exhaustive calculations. Now, I'll show you a quick way to calculate the secondary line voltage in 4 common transformer connections. In star to star, the line voltage ratio equals the turns ratio. For example, if you have 415 volts on the primary with a 5:1 ratio, the secondary is 415 divided by 5, which is 83 volts. In delta to delta, the same rule applies, so again you divide the primary line voltage by the turns ratio. With 415 volts and a 5:1 ratio, you get 83 volts. In star to delta, first pretend both sides are star to star. That gives you 83 volts. Then, because the actual secondary is delta, you divide by the square root of 3 to end up with about 48 volts. Finally, in delta to star, start by pretending both sides are delta to delta, giving you 83 volts. Then switch to star by multiplying that number by the square root of 3, landing at around 144 volts. Memory trick. By sketching star and delta windings side by side, you'll see that star has a higher line voltage than delta. That mental image will help you remember whether to divide or multiply by square root of 3. Alright, now that we've covered how to calculate the secondary line voltage in the 4 configurations, take a moment to practice these steps with a few examples on your own. Try using different voltages and turns ratios to test your understanding. Once you're comfortable with voltage calculations, we'll move on and introduce a quick shortcut for calculating secondary currents. Just like with secondary voltages, there's a quick way to figure out secondary line currents in a 3-phase transformer by flipping divide or multiply steps used for voltage. Here's a streamlined guide that keeps things simple. Star to star, multiply the primary line current by the turns ratio. For example, if the primary is 10 amp with a 5:1 ratio, then 10 amp times 5 is equal to 50 amp on the secondary. Delta to delta, same rule, multiply the primary current by the turns ratio. Again, with 10 amp at a 5:1 ratio, the secondary current is 50 amp. Star to delta, first pretend both sides are star to star. Multiply the primary current by the turns ratio, 10 amp times 5 is equal to 50 amp. Then, because the secondary is actually delta, multiply by the square root of 3, giving around 86.6 amp. Delta to star, start by pretending both sides are delta to delta, so 10 amp times 5 is equal to 50 amp. Next, switch to star by dividing by the square root of 3, ending up with about 28.9 amp. Alright, now that we've covered how to calculate the secondary line current in the 4 configurations, take a moment to practice these steps with a few examples on your own. Try using different currents and turns ratios to test your understanding. If you need extra time to work through your calculations, feel free to pause the video until you're finished. We've explored quick methods to calculate both secondary line voltage and secondary line current for 4 common transformer connections: star to star, delta to delta, star to delta, and delta to star. By applying simple shortcuts, dividing or multiplying turn ratio, and using or not using the square root of 3, you can skip lengthy formulas and still get accurate results. Practice these techniques often, and you'll soon handle transformer calculations with ease.